Hello, my name is Ho-Jin Jang in Chemical Engineering at Sungkyunkwan University. In this time, I will present about the emission color management of dual emitting OLEDs by selective switching of phosphorescence through host engineering. Before start topic, let's talk about room temperature phosphorescence. Phosphorescence is emission from triple exciton energy release, so phosphorus with heavy metal atoms can emit phosphorescence due to its strong spin-orbit coupling SOC and intersystem crossing ISC. The room temperature phosphorescence RTPH is similar to phosphor emission mechanism that induces SOC with a large molecular number atom, but not using heavy metal atoms. So, RTPH is organic phosphor without heavy metal atoms. Also, these type emitters can emit not only RTPH, but also TADF. But ISC and SOC of RTPH is much slower than general phosphor, so triple exciton lifetime is millisecond scale. Therefore, even host triplet energy is higher than that of RTPH, triplet back energy transfer is possible if it is not enough high above 0.5 electronvolts. With this property, dual emission component of the emitter can be controlled by managing back energy transfer and host triplet energy. In the high triplet host, RTPH component would be highly remained, and in the opposite case, RTPH component would be quenched and TADF component ratio would be increased. So, for this research, three hosts and one dual emitting material is selected. Two hosts have 0.5 electronvolt higher triplet energy than dopants, and else one doesn't. And dual emitting material has a yellow emitting RTPH and green emitting TADF. In the PL spectra and the TRPL curves of dual emitting emitters in different hosts, DPPO and MCBP host samples showed relatively low quenched RTPH emission and long-lived delay component curves. But DPBCZ showed highly quenched RTPH emission compared to TADF emission, and sharply decreased TRPL curves, indicating that not enough high triplet energy host cannot block back energy transfer and relatively enhance TADF emission. With these photophysical data, device EL spectral analysis was carried out with this device structure and three kinds of hosts. The EL spectral of DPPO and MCBP host devices showed yellow RTPH dominant emission and switched to green TADF dominant emission as driving voltage is increased. Whereas DPBCZ devices showed relatively low ratio yellow RTPH and completely quenched as driving voltage is slightly increased. In conclusion, dual emitting RTPH emission ratio can be managed by selecting various triplet energy state hosts. For high ratio RTPH, much higher triplet host is required, and in opposite case, low triplet host is proper. So, by changing host, we can emit various emission with only one dual emitting emission material. This is the end of the chapter. Thank you for listening.